Assalamualaikum warahmatullahi wabarakatuh and a very good day to the panels. My name is Mohammad Fitri bin Hussain, currently a final year student from Faculty of Mechanical Engineering in UiTM Shahriman. The purpose of my presentation today is to present to you about my final year project entitled Finite Element Analysis Approach on Role Forming Process. This study is under the supervision of T.S. Dr. Muhammad Shahriman bin Adenan. Throughout this presentation, there will be 7 sections that will be discussed about the project. The sections will be project summary, introduction, problem statement, objectives, literature review, methodology, and the expected results of the study. In summary, role forming process has been researched by a number of researchers ever since the early days of the FEA software. Recent researchers still use the same approach of analyzing data obtained from the FEA solver. Nowadays, FEA method in analyzing the manufacturing process is widely used. This is due to the technological advances and capability of the hardware. By implementing FEA on certain manufacturing process, data and information on the process can be obtained and further optimization can be done to the existing process. This is to further increase the productivity and quality of the process. In this section, I will discuss about the background of the proposed study. As we all know, roll forming is one of the many forms of sheet metal forming that can be found in the manufacturing field. For example, the automotive sector is one of the many manufacturing sectors that benefits from the roll forming process in producing parts such as door panel, car bumpers, and etc. So, what is roll forming process exactly? Roll forming can be referred to as a process which involves incremental deformation of the metal sheet that is passed through a set of rollers. The fundamental setup of the roll forming process is the rollers and the sheet itself. In designing the rollers, it is very dependent to the geometry of the final product. In order to make a proper design of the rollers, FEA method can be adopted to predict the material behavior during the roll forming process. In the roll forming process, the sheet experiences a multiple degree of deformations. The deformations are usually experienced when the sheet comes through the rollers. So, how can the sheet being deformed? This is mainly due to the loading being applied to the sheet. As we all know, every metal and material have their own yield point. So basically, loading beyond the yield point of a certain material or metal will result in the plastic deformation, which is a permanent deformation. During the occurrence of this phenomenon, several mechanical properties such as the stress and the strain can be obtained. The flow curve, which indicates the flow behavior of the metal, can be mapped using the data recorded during the roll forming process. In doing this study, the first thing is to identify the current problems that arise regarding the roll forming process. The first problem is that the traditional method that is still being used by some of the manufacturers is not that relevant anymore. Manual major and minor tweaking are a hard process and it requires skillful technicians. This can also increase the cost and the time taken for the tweaking and fine-tuning process. With the increasing demand in FEA on roll forming process, it is one of the factors that contribute into the idea of doing this study. To cope with that trend and the technological advances, a study on FEA for that particular manufacturing process should be done. The last problem is that the data on the sheet is not easy to obtain using a traditional method. This problem shows that FEA is needed to be present in the manufacturing process to develop data that indicates the condition of the sheet going through the process. There are three objectives for the proposed study. These objectives are focused on the FEA implementation in roll forming process. The first one is to present the data on the material behavior during and after the roll forming process along the metal sheet. The second one is to validate the results obtained from FE analysis with the experimental results. The last objective is to implement FE analysis techniques in creating a reliable model that suits the demand and the purpose of the product. The first literature is about the FEA in designing the roll forming process. Past researchers have been studying on the roll forming process to actually predict the material behavior during the roll forming process. In doing so, they found out that the FEA software implemented during the manufacturing process can significantly reduce the time and cost of manufacturing. This is mainly due to the fact that FEA software can eliminate unneeded process and tryouts for the fine-tuning process. Not only that, defects on the material during the roll forming process can also be pointed out by analyzing the material behavior during the deformation. As we all know, accuracy is the main important thing in maintaining the quality of a certain product. Thus, it is very crucial to get the most accurate data on the roll forming process. FEA is confirmed to have accurate results when it is compared to the experimental result that is done in the lab. Several researchers have found that their simulations are similar to the experimental results. There are, however, small discrepancies, but it is negligible. The graph on the right shows one of the findings that is obtained by using the simulation. Notice that the longitudinal strain obtained is similar to the graph map using the experimental data. This shows that the FEA is relevant and can be implemented to predict the metal behavior. The study on the sheet is one of the main literature in studying the roll forming process. It is stated that the longitudinal strains during the deformation will increase over time even after the sheet has passed the roll axis. The longitudinal strain development can be affected due to the several parameters. The graphs on the right shows the effect of different parameters to the longitudinal strain development. The first graph shows that the increase in thickness of the sheet will increase the longitudinal strain, while the other one shows that increasing the deformation angle of that sheet will increase the longitudinal strain. Other research suggests that strain hardening exponent also plays a role in the deformation length, as it indicates the plastic and elastic behavior of the metal. Thus, parameters of the sheet, or parameters of the process, can play a big part in the longitudinal strain development. In this study, there are two methodologies that are being used. The first one will be the general method in completing the work or the simulation, while the other one is the methods that are being used inside the FEA software itself. The first methodology is the general flow of the simulation. The overall methodology will be based on the flow of completing the simulation using the FEA software. Actually, the methods that are going to be presented in this section is basically the typical FEA algorithm. It consists of three stages, with the first one being the pre-processing phase, solution phase, and post-processing phase. The pre-processing phase involves mainly the modeling and the meshing of the rollers and the sheet itself. Solution phase is done after the modeling, enabling the solver to solve the analysis. Post-processing phase is referred to as the final result that can obtain the data and sheet analysis of the manufacturing process. Keep in mind that fine-tuning process also included in this process, where certain parameters being modified to satisfy with the result. For the next methodology, it is focused on the FEA software. The FEA software that is going to be used in this study is the SIMUFAC. Parameters that are used are taken from the past research on the used channel. The material presented is the equivalent to the AISI 1015 carbon steel that are commonly used in manufacturing process. As for the hardening rule, Swift model is used to simulate the behavior of the metal. The important components in the model is the plastic strain, strain hardening exponent, hardening coefficient, and the flow stress. These flowcharts explain the step-by-step process of doing the simulation using SIMUFAC. Drawing the rollers can be done by using CAD software. Keep in mind that only the 2D cross-section of the rollers need to be drawn, as SIMUFAC will revolve the rollers when it is imported into the software. Initial sheet along the material is created. The sheet is only half of the symmetry to reduce the completing time. Thus, a symmetry plane needs to be established alongside the constraint plane. Contact table then will be defined, and the last step is to run the simulation to obtain the data on the process. During the course of this study, the results that are expected to be obtained are being identified. It is expected to validate the results using the simulation with the experimental value with low discrepancies, as suggested by past researchers. The overall geometry is also expected to be the same with the experimental geometry of the product. There are, however, flaws that are expected to present in doing the simulation. This is due to the algorithm of the software and some are limitations on the software that is being used. These are the preliminary results that I have obtained during this study. As you can see on the left, the suggested wallflower diagram is similar to the one that I have modeled using SIMUFAC forming. As for the setup of the rollers on the right, it is confirmed that the interstand distance between the rollers are sufficient to let the metal sheet to deform and flow normally without any error. The final product obtained is the U-channel using 3 incremental stages. That's all I can share with you for today regarding the FEA in roll forming process. I hope that my explanation can give you the general idea of doing FEA on roll forming process. In conclusion, FEA approach in roll forming process is very crucial in developing the process by benefiting from the computational abilities on producing accurate data on the metal sheet during the roll forming process. If there are any questions or inquiries regarding the topic, let me know by contacting me using the following mediums. With that, thank you and stay safe.